right, hello, welcome to the October 2016 Get Started with CyVerse. I'm Jason Williams, coming to you from Cold Spring Harbor Laboratory. Over the next hour, we prepare this webinar to give new users a little bit of an understanding of some of the capabilities, tools, platforms, and services that CyVerse has to offer. So welcome, thank you for joining us. We will be doing this live, so we actually encourage you to participate by asking questions. In fact, let me tell you a little bit about the room that we're using in this Adobe Connect webinar. At the bottom of the screen, you have the ability to ask questions, so at any time during the presentation, please go ahead and send me a question if you have it. The entire webinar will be recorded and posted to YouTube shortly hereafter, so if you do miss something or want to go back, you'll have the ability to watch the recording. Also, some important things for you to think about while you're watching the webinar. Number one, at the top of the screen, there is a little button where you can press and actually make the video itself full screen. And that will be especially useful when I show you some things on my computer. I can only make it look so big, so watching things full screen may help. Also, on the side of the room, you have the option to download the slide deck that I'm using. And there are also some helpful links that you can click on, and those will navigate you to some useful places and websites within CyVerse. If you are watching this, depending on your connection, if you move your mouse over the video, you can also adjust the quality of the video from a high definition to a lower quality if you have a lower bandwidth or any type of connection issues. And as for any type of connection issues or sound or anything, again, if you have an issue, please let us know by chatting off to the side here. I can see that on the screen. If you have any major issues, usually just leaving the room and coming back will be sufficient to fix that. Okay, so the presentation for this hour consists of a short introduction to the overall CyVerse project. Many of our users hear about us from their colleagues, but they've never actually heard directly from us, so we'd like to give you a little bit of an introduction, pretty short, to what the project is, what our goals are, what we're about, and also some of the pieces of technology that you may or may not know exist within CyVerse, so that you have an idea of the sort of 10,000-foot view. Then we'll spend most of the time actually on some important demos. These are some of the first things that you'd need to do in order to get started using the platforms, and that includes how do you actually move your data back and forth from your computer, from your laptop, your server, up into CyVerse. Also, how do you download those data, how do you share those data. Then we'll give you some quick examples of how do you conduct an analysis using our web platform, the discovery environment, and also using our cloud platform, Atmosphere. So we'll spend most of the time on those demos. So let's go ahead and get started. One of the first things we want folks to know about CyVerse is the vision of the project. And the vision for the project is to enable scientists to really be data-driven in their research. So transforming science through data discovery for us means that we give scientists at all levels the ability to manipulate and manage data. Some of you may be working at the bench, and that's most of your research activity in the bench, in the field, collecting data, but you may not have done the analysis yourself. Others may be bioinformaticians, programmers. We really have a wide spectrum of users, and we want to enable discovery for all of them. Now, our mission and the way we actually accomplish that is by designing this cyber infrastructure and also training scientists on how to use it. So we have more than 30,000 users. We have more than 1.5 petabytes of data, hundreds of publications. Folks use us for courses, and of course many discoveries come out of this effort. Many of you may actually know CyVerse as a project by its former name, which was iPlant. So starting in 2008, the project was funded as the iPlant Collaborative. And as the project evolved, including its renewal by NSF in 2013, our mission became broader to really service not just plant biologists, but entire life science community. And this year, we renamed the project CyVerse to really reflect that broader mission. One of the really key things about CyVerse, what actually makes it all possible, is that we are an entirely NSF-funded project. This means that we really are your colleagues and your collaborators. Most of us work on a variety of scientific goals and projects, and it's $100 million of investment that NSF has placed into the project. So it's a really nice, large set of resources, and it's really there for you to use however however you find it useful. So we don't say that CyVerse is the solution to every problem, but what we encourage investigators to think about are what are the parts of your analysis and your data workflow that actually cost you money and time, and if you can do those efficiently and even at no cost directly through CyVerse, then it's really worth it to take a look into these resources, use what's useful, and leave the rest. The other thing about CyVerse is we're totally open to collaboration. So whether you're a national user here in the US or international, we have users all over the world. And we also remind users at every level and every project to please think about, as they publish, as they work, not only sharing us with your colleagues, but also citing us, because that's a way that we demonstrate the impact of the project. Okay, a quick definition, because I've used this term. What is cyber infrastructure? So this is a term that we use a lot within CyVerse, but it really doesn't mean anything more than these terms you're already familiar with. So what we give you access to is data storage, software, high-performance computing, and also people. We try to provide all of those layers of what is really defined as cyber infrastructure, and it's really organized in a way that is well suited for the type of research that most life scientists are conducting. And it really allows those scientists to analyze and tackle problems of size and scope that otherwise wouldn't be solvable. Now, what's not solvable, that's really up to an individual investigator, where they need a new tool, they need a new capacity. But for each one of those, we really can provide something that can help them go to the next level. So platforms, tools, and data sets, we'll be talking largely about that. The storage and compute, if you're a developer, we could go into detail, although not in this webinar. And then training and support, today is an example of that. The other thing that's a really important message for us is that we support all domains of life science. So whatever type of research you're working with, CyVerse is built for data, and we really invite our investigators to become comfortable thinking about using us for a variety of their analysis needs and problems. This is a high-level overview of what we call the CyVerse product stack. At the top layer are the actual things that most of us will use. You'll go onto a website, you'll click on Atmosphere, you'll start the discovery environment, and that's what the demos will cover. But beneath that, there are a variety of technologies that do everything from make it easy to search your data and make sure the data is secure because of authentication, to at the lowest level, the actual systems that we run on. This is important to some of us because also CyVerse is not dependent upon what you're using it. You're sitting on your laptop or your computer. You don't have to worry about what your local capabilities are because everything is within CyVerse. The only other thing I'd say about this diagram is that if you are a developer, then you actually have ways to access all of these layers independently and in a very customizable way. So it's really open to development, and in fact CyVerse is totally open source. Wrapping up this sort of description of the project, I just want to comment on how CyVerse was built. Again, I said this started in 2008, and it was really clear, particularly within life science, maybe even new in some ways to life science, that data is going to be the currency of modern biology. And so it was always a community project. Gathering requirements and understanding input from community members drove the development of CyVerse. Some of the priorities, and these are some of them that were identified even back in 2008, are really the same today as they were a few years ago, and probably many of these will continue to be the same for the foreseeable near-term future. Big data within biology is definitely driven by genomics, and so when you come to CyVerse, you'll find all the tools that you need for everything from assembly, variant calling, looking at epigenetics with ChIP-seq. There's really sort of a handful of really core workflows that most users are coming to use, but really all of these are things that we support. The other thing about CyVerse is that we ourselves are quite diverse. So we're made up of a core of 4 institutions at University of Arizona, University of Texas Austin at TAC, which is the Texas Advanced Computing Center, Cold Spring Harbor Laboratory, and UNC Wilmington. There's also an analog to CyVerse within the UK, CyVerse UK, which is made up of several universities and institutions and funded by BBSRC. Okay, so I've talked to you a little bit about the project itself and history. Now I want to get into the actual pieces that you can use. And I just have this little metaphor that we sometimes use of thinking about us as Lego bricks or Lego blocks. We have several pieces of of technology, a software that you have the ability to use. And really, it's a matter of taking those pieces. We built 85, 95% of what you need, and you can actually do the rest. I do see that one of our users has a hand raised. I'll just encourage you to go ahead. If anyone has questions at any time, at the box below, feel free to ask any questions that you have of me. Okay, so back to that metaphor while I wait on potential questions. What we have are the individual pieces that might make up your workflow, that may make up your data storage and backup solution. You can take what we built at the face of it, or you can customize it. What are some of those pieces? Okay, so at the base of it is the data store. The data store provides all the resources you need to manage and share data with your lab, with colleagues, and with the community. Every user has an initial 100 gigabyte allocation. If you need more than that, you can have much larger allocations. You just need to fill out a support form, and it's still free for our academic users. The data are automatically backed up, so it's quite safe. We've never lost any user data, and it's quite easy to upload, download, and share, and we'll show that in the first demo. The discovery environment is another tool that we really think is really important for folks to know about. Within the discovery environment, we have the ability to give users a web interface, and through that web interface, they have the ability to access and manage data, run analyses using a variety of applications, and it's also extensible, which means if there are applications you'd like to use within the discovery environment that you don't see, it's quite easy to add them. In fact, if you are a developer, you can also think about adding your applications because everything is Dockerized, and you have the ability through Docker to bring your applications within the discovery environment. Next tool is Atmosphere. We'll be giving a demo on that. Within Atmosphere, you also have the ability to go ahead and use virtual machine images. If you're not familiar with cloud computing, I'll talk a little bit about what that means. You can fully customize your software setup within there, so you don't have to wait for an administrator to install a tool. And it's also quite powerful because it's integrated with our data resources. The Science APIs are really for developers, and that is the way that folks who want to do some coding within CyVerse and actually build their own applications or build their own workflows at the level of the API are totally able to do that. DNA Subway is a product for the classroom. We have several bioinformatics workflows that we enable teachers and students to work on. In many cases, really supporting inquiry-based experiments, so real classroom experiments, and supported by a bioinformatics platform that is classroom-friendly. Bisq is our setup or our platform for working with image data. It handles several hundred different image formats, and if you need to manage dozens, hundreds, thousands, millions of images, essentially Bisq is a system that is allowing you to programmatically analyze and manage those types of data. Okay, so that was another high-level overview of the individual products that are a part of CyVerse. Now what we can actually move on to is the demos. Again, I'll remind you that this whole presentation will be recorded, so I'll try to go through at a reasonable pace, but if you miss anything, we'll let you know as soon as the video is posted to YouTube, and you could go back and refresh and look at that. This might also be the time where you want to take your mouse up to the button on the top of the screen where it has those 4 arrows. You can choose to make it full screen. It might make for better viewing. Okay, so first let's talk about the CyVerse data store. As I mentioned, the data store is going to allow you to store any type of file related to your research, move those files, automate transfers of files, and share with lab members, collaborators, and the community. There are 3 basic ways that most users will work with uploading and downloading data. They include CyberDuck and also the discovery environment, which are both graphical interfaces, and then also there's a command line interface called iCommands. I'll demonstrate these all in one way or another in the next few moments. The discovery environment is our analysis platform, but also allows you to manage data. We really wouldn't encourage users to upload and download large data sets to the discovery environment because it is a web interface. Pardon me. It works through standard HTTP protocols, and that means that it's going to be slower than you can otherwise achieve using some of the other technologies. The discovery environment is great, however, for sharing, and we'll talk about that and emphasize that feature. CyberDuck is probably for most people the single tool that they'll use to upload and download really large files, whether you have gigabytes or maybe you have a terabyte of data you need to move. CyberDuck is up to the task. It's really quite simple drag and drop interface. It works very much like a Dropbox in that sense. And there aren't too many minuses to CyberDuck. It does not interface with our metadata system, but that's a separate issue, and we certainly are not going to emphasize that for CyberDuck, but in terms of just moving data back and forth, we'll talk about downloading and getting CyberDuck running. iCommands really lets you do everything. It's also quite fast, so if you do have to move large data sets, that's another great way. And of course, it happens at the command line, so it's completely scriptable. Okay, so let me give you a quick demo and show you around how to get started with CyberDuck. The first thing I'll probably suggest is that you take a look at our CyVerse homepage. We're actually making some significant updates, but even right now, one of the first things you might want to do is think about going ahead to the CyVerse Learning Center. And from the Learning Center, one of the first things there will be about managing your data. So if you lose me, I don't really expect people to be following me step by step, but if you are, you'd come here and you'd see, for example, that you could go and work with CyberDuck. So here's a link for CyberDuck, and we could click on that first one about using CyberDuck with a CyVerse account. And essentially all of the instructions, quite small on my screen, are here. So what you'll need to do first is download the CyberDuck tool. That's one download that you get. It's a free software, although it's by different, it's not associated with CyVerse. It's an independent group that makes the software. And you can also choose to donate to them, but it's free. And you'll also need to download this thing called the connection profile. So really, this whole step 1 and step 2 will take you less than 5 minutes. Go ahead and start downloading it. Go ahead and start setting it up. Let me show you what it looks like and how it works. So I have CyberDuck running on my computer. But let me start from the beginning and just open a new instance of it. Actually, I could do it this way. So when you start CyberDuck for the first time, it will be this sort of blank screen, and it will have a bookmark, which is essentially, once you follow our instructions, the way that you connect to the CyVerse data store. So you'd click on that, and within a few seconds you'd be connected, and what you will get, sorry, can't make these windows much bigger, but you can view this full screen. What you will get is this window on the right, which is actually a look into the files and folders that I currently have in my personal CyVerse data store. So if I wanted to move files and folders, I could simply click on a file like the sequences and drag it wherever I'd like on my computer. In this case, I'm dragging it to the desktop. When I go ahead and do that, I'm going to skip the cleanup for right now. When I go ahead and do that, on the bottom here, I get a notification. I get an arrow that's down, so that means it's a download. It'll take a few seconds to start, but then it'll start moving, and we would expect that you move somewhere between 100 gigabytes, somewhere around the order of 30 minutes for 100 gigabytes to do that upload on a decent connection. The same way, if I wanted to take a file and I wanted to move it into the CyVerse data store, let me just create a new folder called temp, and you could assume that that has some data. If I wanted to take this folder and move it into the CyVerse data store, I would just drag it over. It would ask me, do I want to go ahead and drag that over? And then I get the notification that here is an upload that's going to be in progress. So I have a history there. This is also quite nice if you have interrupted downloads. You can essentially resume, or you can make sure that things were uploaded or downloaded successfully. But it's really just that simple. It really is drag and drop. There's not very much more to show you. On the left-hand side, I can also preview files. I can take a look inside folders and see what's there. It takes a moment to load, but essentially I could go through and just get an idea of where my data sets are and how I'd like to move them. That's all there is to CyberDuck. As I said, whether you have 1 megabyte or you have 100 gigabytes, it's just going to be a drag and a drop to move those files. Okay, so let me talk about another way to move data, and that's going to be using iCommands, which is a command line interface. If I go back here to the CyVerse website, This is on that managing data link that I showed you in the CyVerse Learning Center. And again, if you miss anything, please feel free to give me a question. Down here is the link for iCommands. Oops. I moved a little bit too quickly. So you can go ahead and click on the CyVerse account and look at that. And it will give you some ideas about how you go to download iCommands and also set it up. Now this I've already set up on my computer. So I'm just going to go ahead and open up a terminal. And let me open up one that's a little easier to see. Okay. So here's my terminal. When I first start iCommands, the iCommands are a variety of individual binaries that you could execute. The IINIT and all of the iCommands start with an I, so iInitiate just logs you in. If it was the first time you're running, you'd have to configure it, but for me, I can just enter my password, and it's my CyVerse password. Nothing happens, which means that it's properly configured. And now I can view things, for example, in Linux, you know, ls would give me the contents of a directory, so ILS gives me the contents of my CyVerse data store. And this is the same collection of data that I saw a moment ago using CyberDuck. And if I wanted to move some folders or files, I could do that as well. So I could use, for example, the iget command, which is the command to download. If I'm going to get a folder, I'm going to make it recursive. I want to see the progress. I want to get the time. I want to be verbose. And I can do this VCFs folder that I see, and I could move that to my desktop on my local computer. On the right-hand side, you could see that the folder is there, and then I got progress because that download is already completed, and I saw, you know, step by step what was going to be downloaded, and that folder is on my computer. The same thing if I wanted to view the contents of a directory or upload, which is an iPut. Basically, you follow the documentation where there are examples given to you there. You can go ahead and use the iCommands to do a variety of operations, everything from managing metadata to checking checksums. iCommands really gives you a lot of power to do that. The final thing that I'll show you is how to manage and share data in the discovery environment. So let's assume that you've uploaded a whole bunch of data. Now you want to look at it, you want to share it, maybe even do some analyses. Here I am again on the CyVerse homepage. I'm just going to go ahead and click on Discovery Environment, and then I'll get a link at the bottom to launch the discovery environment. I'll have to log in with my CyVerse credentials. I already have something open, so I assume that I'm already logged in. I'll give it a second. Because I'm already logged in on this window, so I can just go over here and start showing you. Okay. It didn't like that I was logged in twice, that's why. There we go. Or that I had two windows open like that. Okay, so this is what the discovery environment is. Let me just close these extraneous windows. We'll talk a little bit about it, a little bit more about it in just a moment. But for right now, what you can think of the discovery environment as a very, very simple pared down desktop that has a couple of applications that you can use. The first one that we'll talk about now is, since we're talking about data, is data. And when you click on that, you're going to get this window, which has a number of options. And if we want to see our own personal data, that's in a place that is synonymous with our CyVerse username. So I'll click on mine. And this is, again, the same collection of data that I saw in CyberDuck and iCommands, folders, files, all within the CyVerse data store. On the left-hand side, there's also community data, which are data sets which are shared with everybody. You could also place things in community data if you want them to be shared with the world. You could request a DLI for them. There's so many things, I just don't have time to share them all in this moment. Shared with me are data sets that are shared individually with you, either by some CyVerse services or by other users. Trash you can understand as a temporary place for deleted files, and favorites, you can star individual files or folders to put them in your favorites. But let's quickly talk about sharing data real quick. If I have a file that I would like to share, and this particular capability I'm about to show you, which is called a quick share link or share link, only works for individual files, so not folders. I can select that file, go up to share, and say create public link. When I do that, I click on that file, click Create, and it will create this URL. I could copy that link, and now, Command-C on my Mac, whoever I give that URL to, I paste that URL into a browser, hit Enter, and they will get an option to go ahead and download that file. These quick share links, which you can also just in fact, rather than click on many things as I did, you could also click on the individual link there and it would do that as a shortcut. These quick share links are a really easy way to share small data sets in a way that I also must make sure everyone realizes is not totally secure, because anyone who has that URL will be able to download that. So you have to be selective about sharing things. If you want it to be 100% secure, then using a link is not the best way, because anyone who has that link could use that, could share it, or forward it to someone else. So once you have used the link and you've shared it, one of the things you may want to do is come back and delete the link. You click that share menu, and each of those links you've created, you can click on the little delete icon and you can delete those data links. The link would no longer be active, so anyone accessing it after you've deleted it would not be able to download. This feature is pretty useful. It allows you, again, to share things. The person who you're sharing with does not need to have a CyVerse data store. Maybe you want to make slides available after a presentation. Maybe you have some other data sets. You can totally use those links to share individual files really quickly without much hassle. Now, if you want to share really large collections of data, I'm going to show you that. Let's select this folder. And this method I'm going to show you works for folders, works for files. It does, however, require that the person you're sharing with does have a CyVerse account. What you do is you select that, then you go up to Share, and now this time you say Share with Collaborators. So I'm going to click on that. If I look under Who Has Access, you can see no one has access right now, so I can search for the name of someone I'd like to share with. And their name should come up along with their institution. I can click on that, and now I can decide how exactly I'd like to share it. If I go back to, let's see if I still have this open. I'm going to just search the wiki, because I think it has a nice little chart about sharing files or folders. What you have the ability to do, here we go, permission levels, is you can share with someone according to this chart that I'm showing you. These are based on the Linux permissions. So if someone has read access, they can read the data and they can download it. If someone has write access, they can even alter the info type, whether it's a FASTA file or FASTQ file. But importantly, they could also rename it. And then own permission gives them everything, including the ability to move that file or delete it. So you really don't want to give own permission unless you completely trust what the other person is going to do with it. So assuming I'm satisfied with just read permission, I would click Done, and then Cornell will get a notification that it's been shared with him, and he could click in his notifications. I'm going to close that up here and see what has recently been shared and be navigated directly to that. It's also available in the Shared With Me folder. Assume that I shared something with somebody and no longer want to share it with them. Let me go back to my home folder. Oops, I want to go back here. Assuming that I shared something with somebody and I no longer want to share it with them, I go up to, for example, Share, and I want to go to this directory. There we go. That was Share with Collaborators. This one I don't think is shared with anyone. I have to, oh, actually this one is shared with several people, so that's a good example. Let me give it a second, because it's going to load everyone I'm sharing this folder with. And you could share with multiple people. You could have a laboratory account and you could use that way, or create a shared folder that everyone in your lab has access to, and that's a great way to share data sets. Okay, this one is shared with quite a few folks, so it's taking a moment to load. I don't want to wait for it. So what you would actually do, let me share something that's not shared with someone else. What you would actually do is back in Share, as you remember, to share the first time, I selected the person, but if it's already shared, you would always see this red X next to the person's name. You'd come back and you'd click that X, and then that would revoke permissions and they'd no longer be able to share it. Now this one wasn't shared with anybody, so I got a little bit of an error message. But that's all that you need to do, and you can either, you would click Done to complete that operation. Okay, so those are the basics on sharing. There's quite a number of data operations that I'd love to show you, but I simply don't have time. But let me just allude it to for a second. One of the really key things about the discovery environment, or about the setup within CyVerse, is that you have metadata that you can attach to various files or folders. Let me just choose an individual item there. So I've selected an individual picture, and you can go and click Edit Metadata. Now every item within the CyVerse has metadata associated with it, some visible, some not. Now arbitrarily I could add metadata, like if this is an image, I could say, you know, location, and it could have a value, you know, 1A, as if it was on a grid, and unit, this one might not have a particular unit associated with it. But you can assign metadata to files and folders, because ultimately we can't name our files and folders intelligently as, you know, time point 1 underscore A underscore replicate B underscore this underscore that. Our file names would become so long it really wouldn't make sense. So instead what you can do, and let me show you an example from a template. If we go to the templates that are available, we have templates for lots of the types of metadata that folks would be using. For example, using an SRA library, or working with an SRA library, I could open that template, and you would see that before I go ahead to upload those files, there's a whole collection of metadata that ultimately is going to be required of me. I could fill out this this spreadsheet, let me say it that way, and upload that with my data set and associate it with that, so that everything is labeled. And then ultimately, when it also comes time to search for those data, I can click on the search, and now I can search. For example, metadata has the words, well, let's look at genus, and let's look at the value Dioscorea, and now I can search anything within my collection of data that has a particular genus and that has a particular value for that genus. It'll take me a second here because it's searching the entire collection, but you get the ability to search really in fine-grained, and it really is nice. So this is an example of some things, and I have some, just as example data sets where I could view the metadata on various things and take a look. So that's quite useful, something to know about. All right, so that is about as much as I have time for to talk about data. Hopefully you got the idea that uploading your data and even downloading it is going to be pretty simple. And then also you have the idea that if you need to share that data set, if it's something small and you just want to share it with the world, you can go ahead and use the quick share link. If you want to share large data sets, you can share it with your collaborators who have a CyVerse account using the functionality I've just shown. It doesn't matter the size of the data set, because whether they're on one side of the world or the other, the sharing is instantaneous because it's permission control. There are other features like metadata, which I didn't have time to mention. There are yet other features. If you want to make those data sets publicly available as part of a repository, part of your publication, those are all features that we support and provide resources for. Everything from submission of your data to the sequence read archive to issuing DOIs and ARC identifiers. Okay, so now we need to move on to actually how to analyze some of those data. Let me go back to some of the slides to orient us, and then I'll show you a quick demo of that within also the discovery environment. Okay, so we just did this little demo, and let me talk about the discovery environment now as an analysis platform. As you said, it's a platform that can run almost any bioinformatics application. It's integrated with the data, as you saw, and it's running on our compute systems. And it's also user extensible, although this time I won't have time to show you how, for example, to create your own workflows or to install your applications, but those are features we support. We've covered data, so I won't dwell here. All of those points are things you hopefully got a sense of. The applications are where the actual applications within the discovery environment are that we can use. And then analyses is where we have history, and we can also manage jobs that are in the process of execution. For this demo, we're just going to choose a very simple analysis. We're going to take some unaligned DNA sequences in FASTA format, and we're just going to create a multiple alignment. That's going to involve looking at the data, using a muscle as the application, and then seeing the job progress and results. Okay, so first, back here in the discovery environment and data, let me just take a look at community data. And in there's a place called iPlant Training, which is now CyVerse Training, and DE Walkthrough. You could see it was also favorited, so I could have just done a shortcut. And here is a FASTA file of some unaligned sequences. Okay, there they are. Wonderful. I'm going to close that because I don't need to look at it anymore. I know where it is. Now what I can do is click on Applications. So Applications gives me a listing of the applications that are available within the discovery environment. There are apps that I might be working on or installing or that people have shared with me. You do have the ability to control who has visibility over apps that you install or customize. The applications are sorted into different topics, or different operations, like assembly. So you can definitely look through, and that gives you an idea of what's available for what. I'm just going to go up to search and type in muscle because I know that my application is called muscle. I may see some versions of it. Number one, if I see a version that's in red, that means for some reason that application is unavailable. Sometimes that means that the application is just running on a computer that's currently not online. If I want to know what an application does, I can click on the little info button there, and it'll give me a summary of what that application does. By and large, we at CyVerse have not written these applications. We've integrated them, so we're not the authors of these tools. But you do get links to the user manuals, and you can have an idea of how the tool works, what the version of it is, etc. To actually, you can also actually rate the tool if it's worked for you. Some tools are rated highly, some tools are not rated at all, but you can certainly take a look at the ratings and comments and see how you'd like to use it. To actually use it, you click on the name of the application, and it opens up in a new window. I'm going to close the window behind me and focus on this one. So all of the applications within the discovery environment look much like this one. The first thing you do in this sort of accordion menu where I get to go through the different steps of the application is give this analysis a name. So I'm going to go ahead and say this is the October 16 demo. I encourage leaving comments. The reason being is that in the wet lab, we often will take copious notes, but when we're doing bioinformatics, we may not be as careful to document, especially when it comes to a command line interface, so please take notes. I also have the option of deciding where the output of the results will go. By default, it's my analysis folder, but I could also default it. If I go up to the right-hand side and click on my preferences, I could say, you know what, I have another folder that my whole lab shares, and I could make sure that by default analyses output to there. But I'm not going to change anything other than what I've written. The next thing is mandatory. I see I've got a little star. The next item here is select the data. I'm going to go ahead and browse. It will browse to the last place I access some data, so that just happens to be good because I want that DE sample plants. I'm going to click OK. And then I have another option that's mandatory, and I know that this is DNA sequence, so I have to select that. I'm going to go ahead and then launch the analysis. On the top here, I'll get a notification shortly that the analysis has been launched. So I'll just wait for that 1 second. And all of the notifications that you get, by the way, are up in this right-hand side where you can see history of your notifications. So that's been launched. And now if I want to check on the status, I can go ahead and click on Analyses. And I'm going to see under Analyses basically a history of the analyses that I have run and what their statuses are. So if I want to take an analysis, let's say I accidentally launched it before I completed some other options, I could go ahead and cancel an analysis while it's in progress and stop it. The other thing I could do is I can add some comments to the analysis, so I could update some comments and add something additional to it. This is really great for lab practice, keeping notes. If I've used an analysis in the past, I can also see what parameters I use. So selecting just this one, if I say view parameters, I can see the parameters. My input file is there. In fact, that's a link to the actual file that I use. That's great. because sometimes my files may be just digits and alphanumerics that aren't really intelligible. I can see all the options that I selected. This really only had one option here, DNA sequence, but it does have multiple file outputs that are by default. Just got a notification that my analysis is running. In fact, I may need to click refresh in order to see that. But my analysis is now under the status running. If I want to look at another analysis, let's look at a longer one, look at Top Hat. And I go to analysis and I say view the parameters. I have many more parameters. And again, this is really important information I need to make my analysis reproducible. I could click Save As and save that actually as a file, a text file that I could use to go back to. The other thing I can do with an analysis is I can relaunch it. If I've done something in the past, I want to change some parameters, I can go ahead and click on Relaunch. And relaunch will enable me to go back to that same application. You notice it opens an application window, except this time all of those fields are filled in with whatever I used. So if I realized I should have chosen a different version of the assembly, I could go back and say, it should have been 19. And I don't have to adjust maybe the 20 other parameters that I used previously. Okay, let me go back to the analysis window and refresh it because I also got the notification that my analysis was complete. Now that it is complete, I'll go ahead and click on the analysis name, and that's actually going to navigate me directly to the output of that analysis, which is in my CyVerse data store. There's the output. I'm going to close this other window behind me, and I can click on any one of those output files, and I'm going to see the result, in this case is actually now some aligned sequence. So if you got that, basically this is a really, really simple analysis. It's not as sophisticated as doing assembly, but the idiom of going ahead to the applications menu, selecting your data sets, and pointing and clicking your way through the application works much the same for any type of application that you're going to use within the discovery environment. I'll also talk about later how to get help if you do need additional help to run a particular application. But that's basically the sense of it. That's certainly enough, I think, to get started. Okay, we have time for one more demo, and that demo is going to be in our cloud computing platform, Atmosphere. So let me give you a couple more slides to orient you there, and then we'll also take a look at Atmosphere. Okay, so I'm going to go ahead and close this discovery environment here and come back to the slide here. Okay, Atmosphere. Atmosphere, and I'll also describe this too because some of us have not really used cloud computing in the sense for scientific analysis, gives you access to what we call virtual machine images, and I'm going to define that and describe that in a moment. It allows you to really customize your software setup, and again, it's integrated with everything else that we provide. So to define cloud computing, I'm going to give you two pieces of information, or two vocabulary words, terms, if you will. The first one is called an image. When we use Atmosphere, or when we use a cloud computing system, we're going to have to select an image that we're going to use. Now, imagine this scenario that you've bought a new computer and you want to take everything from your old computer and put it onto your new computer. So let's say this is the original system, our old computer. We can take documents, files, movies, videos, images, whatever, and put those onto a hard drive. And those individual files, it's just a file. But there's another type of file that you could make, and that file is called an image file. And an image file is essentially a copy of the hard drive. Everything, the configuration, the installation, the tools, all of it is embodied in what we call an image. Now, if I go to that hard drive and I take off the individual files I put on, those are individual files. But with an image file, I actually can clone my new system. I wouldn't have to reinstall software for the first time. I wouldn't have to even change my desktop background, be exactly the same because I started from an image. So an image is the operating system plus all the software and even data sets that you might have. Okay, that's an image file. The next piece of jargon is an instance. So within the CyVerse cloud, we physically have hard drives, CPUs, memory in the form of RAM. And in order to run a computer, you're going to need a certain amount of this. And in fact, depending on your analysis, you may know that you need quite a large amount of memory or CPUs to run that analysis. So you ask us for a certain allocation of that, And then you also, of course, if you're going to build this computer, need an operating system and some software. When you put the two together, the instance and the image, you have what we call a virtual machine. And that is an instance. So those two terms are, for our purposes right now, basically interchangeable. It is a virtual computer that did not exist a few minutes before you launched it, and it's available for you to access at an IP address. This is the equivalent of going down to your Best Buy and picking a computer off the shelf and building it. Some of the instances we provide might be tens of thousands of dollars if you were to just buy them. Rather than doing that, you essentially create them ad hoc, use them, and then dispose of them when you're done. When you come to CyVerse, you can access up to 16-core, 128 gig machines. We're going to show you that you can access them via the terminal, the shell, or VNC. And you can also share your images. Suppose that you build a pipeline, build a workflow, you want to have other people use it, you can use Atmosphere as a vehicle for this. Atmosphere has a lot of advantages. I mean, it's really the same as what could you do if you could have a new computer anytime you needed it. You could run the software that right now are monopolizing your laptop or your desktop. In the discovery environment, it's not possible to run software that have their own graphical interfaces, but in Atmosphere you can. You have full sudo or administrative access, which means you don't have to ask someone to install something. You don't need an administrator, you're the administrator. It's really great for teaching or for laboratory setups in terms of reproducibility, because every instance is always the same, it's a clone. So you really understand that people using an instance are using the same software setup. You don't have to worry about that they're missing packages or missing some dependencies. And it's also a way to distribute, in that sense, your own software, your own code. I'm going to give you a demo, and that demo is going to basically show you how to launch and connect to an instance. As I mentioned, there are several ways to connect. Some instances actually have a desktop, in which case you'll need or want a VNC viewer, but all instances you can access via the shell. You'd have to use PuTTY if you're using Windows, although that may change when Windows has Bash. Okay, so let me actually show you how that works. Again, from the CyVerse homepage, you could go ahead and click on Atmosphere, and you'd find a link to Atmosphere. I already have Atmosphere running. So when you launch Atmosphere for the first time, you see a diagram of what you're using. In fact, it looks like I'm over my allocation. But you do have an allocation of a certain number of hours and CPUs you could need. You see in bold, we ask if you need more, please let us know. We do try to accommodate everyone. But at the very beginning, you'll say you want to launch a new instance. So the first thing, if you're going to need an instance, you know you're going to need an image. And if you look, we provide several hundred images that are software combined with, well, operating systems combined with software. So you might say something like, well, you know what, I need something to do RNA-seq with. And so you might type in your search term, and you might see various instances where there are some type of RNA-seq related tags attached to it, and they may have those software associated with it. So assuming that you want to launch an instance, you click on that instance, or rather that image, and then you can go ahead and say click on launch. Then you could choose the size that you need. Depending on what you have access to, you can select larger sizes. Again, these may not all be available at the exact instant that you want them. There are a limited number of some of the larger ones. But once you select what you need, I'm going to go back to the Workshop Cloud, you just click Launch, and then in a few minutes you'll have access to this. There are some other options I'm not emphasizing here, like renaming it, etc., but you get the idea. You'll just click Launch. Now, if I go back to my projects here and see what I have running, I do have an instance that's running. If I see it has an IP address that you're going to need in a moment to connect to it, if I click on that instance, I get even more features, and I'll come back to these in a second, but at least see that this one has 1 CPU, 4 gigs of memory, and 30 gigs of space on the disk. So I'm going to copy this IP address, and then if I want to view the desktop, I've already installed VNC Viewer. There's links to this everywhere in the wiki. I paste in that IP address, followed by a :1, and then click Connect. I enter my CyVerse username and password, and then I'm connected to this virtual machine. And it's just really a remote computer. There's certain software that's already installed. I could go ahead and say, well, you know what, I want to use RStudio today. I could go ahead and double click on that and launch that. You get the idea that you can really do anything that you'd want to do on your own computer on this virtual computer. I can also connect to this via the terminal or the shell, so I could click here. I can SSH my CyVerse username at that IP address. It'll ask me for my password. And now I'm connected to that one. I could, as an example, make a directory. And that directory will appear there as well. So however I want to connect, I have the ability to use that virtual machine to run some analyses. It's completely self-contained. There's no runtime limit. I can go ahead and execute anything in a custom way. Now, when I'm not using my machine, I can go ahead and stop or suspend that. Those will affect my allocation, so that I'm not spending those CPU hours I have. Have an issue, I could reboot it. Let's say I install some software, I want it to be there the next time, I could image that instance. Finally, once I'm done with it, what I really want to do is come back and delete it. I should not delete it without transferring those any data off onto another permanent location. And very often what that's going to mean is transferring it back into your CyVerse data store. So when you start your instance, it doesn't have any of your data store files. You need to copy those on. And then when you finish using the instance, you'll want to copy it off, because once you delete an instance, as I'm about to do, I won't do it yet, but all data will be lost and none of us can recover that for you. So be careful that you've saved everything to another location before deleting that instance. Okay? But that gives you an idea, hopefully, that you can launch any one of these virtual machines with a wide variety of software and operating systems, basically at will. Okay, so the last couple slides here are going to wrap things up. I'm going to encourage anybody who has questions to go ahead and submit those. The last things to pay attention to is where to go from here. So I encourage you to go back to the CyVerse website and view the CyVerse Learning Center, where you have the ability to look at the Get Started guides, tutorials, documentation. We're undergoing a refresh, so we expect those to get even better, but there's quite a lot there. Another thing to take a look at the CyVerse homepage is also the CyVerse Ask CyVerse. If I go down to the bottom, there's a link here to ask. It's also in the Learning Center. And this is our user form where you can ask questions. Many of the questions you might ask have already been answered, but maybe you have a new question, so please feel free to ask it there. Another important way to get answers is you can certainly email support at CyVerse, and they'll be able to help you with additional questions. Also, as far as our training, come to the Learning Center. You can also contact me. You can ask us for workshops. We do in-person workshops. We can often also put together some virtual training for groups who'd like to do that, so you can let us know. So at this point, we're done with today's webinar. Thank you for joining us over the last hour.